Hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I am going to teach you about random forest, and I'll be taking an example of classifier as well as for a regressor. And if you want to study mathematics behind a random forest, then you need to read a book, An Introduction to Statistical Learning, and you can download it in free from this website. If you have not watched my previous videos, you can go ahead on my channel KGP Talkie. There I have taught about decision tree, SVM, logistic regression, linear regressions, and other Python lectures for machine learning. Okay, so in this lesson, I'll be talking about first what is the random forest, and then how it works, and then finally what is the feature importance in a random forest, and then what is the random forest and the decision tree, and then finally we will start working with an example for a random forest as a regression, and then after that I'll work with a random forest as a classifier with iris dataset, and then finally I'll calculate the feature importance for a classifier, and you can also do a feature importance for a regressor as well. Okay, so this is all about in the introduction. So without wasting a time, let's go ahead and start our brand new lesson about a random forest, classifier and a regressor. Random forest is a type of supervised machine learning algorithm based on ensemble learning. Ensemble learning is a type of learning where you join different type of algorithms or a same algorithm multiple times to form a more powerful prediction model. The random forest algorithm combines multiple algorithms for the same type, that's in the multiple decision tree, resulting in a forest of trees. Hence the name of the random forest. And the random forest algorithm can be used for both regression and the classification task. In this lesson, I'll be taking an example for a regression as well as an example for a classification. Previously, as I have already told you that I have already taken a lecture on a decision tree. So in a random forest will be making a lot of the decision tree, and then finally it will be mixing, it will be averaging the results of each decision tree. And if you can also go ahead to my channel KGP Talkie, and there you will see here a decision tree in a Python with an example of a classifier as well as for a regression. Okay, now let's go ahead and start our random forest classifier and regression machine learning tutorial. So the random forest has a variety of applications such as recommendation engines, image classification, and feature selection. It can be used to classify loyal loan applicants, identify fraudulent activity, and it can be also used to predict diseases. It lies at the base of Boruta algorithm, which selects important features in a dataset. So the moreover, what I would like to say is here is that with the random forest algorithm, you can also identify the importance of the features. So the moreover, this is the kind of the forest of the trees. There, for each features, it make a different trees, and based on those trees it predicts the results. So let's say we have 4 type of the classes, class C, D, B, and A, B, C, D, and based on these features N1, N2, N3, and N4, it predicted these classes. And after that, these classes, it will work with the majority votings, and there are other kind of the voting techniques, but here it's a more general, it's a majority weightings voting. Otherwise you can say the averaging, and based on that it will make a final class. And if you see here, based on these four the trees, it will make a final class, which is a class C. Now the question comes, how the random forest algorithm works. Okay, so technically it is an ensemble method, and based on the divide and conquer approach, and it divides the decision trees in so many individual trees, and then finally it conquer those trees and it do the ensembling based on the outcomes of those trees. And this collection of decision tree classifiers is known as the forest. Okay, so these are the collection of the trees, and the individual decision trees are generated based on the attribute selection indicator, which is also a feature, and then based on the attribute selection measure, if you go in my decision tree, you will see here I have taught about these attribute selection measures, and those attribute selection measures are in general information gain, gain ratio, and the Gini index. Okay, so based on those, it makes these forests of the trees, and then each tree depends on an independent random sample. And in a classification problem, each tree votes and the most popular class is chosen as a final result. And in the case of the regression, the average of all the tree output is considered as a final result, and it is simple and more powerful compared to other nonlinear classification algorithm. So the moreover, in a 4-point we can say how this random forest algorithm works. Select random samples from a given data set, then construct a decision tree for each sample and get a prediction result from each decision tree, and then perform a vote for each prediction result if it is a classifier, and do averaging if it is a regression. And then finally select the prediction result with the most votes or average of a final predicted values. Now let's go ahead and see how decision tree helps you to find out what are the important features in your data set. In random forest can identify even a single important feature in your data set. Random forest offers these the selection indicators, and the scikit-learn provides an extra variable with the model which shows the relative importance or a contribution of each feature in a prediction. It automatically computes the relevance score of each feature in the training page. Then it scales the relevance down so that the sum of all score is 1. And the random forest uses the Gini importance or mean decrease in impurity to calculate the importance of each feature. And the Gini importance is also known as the total decrease in the node impurity. And this is how much the model fit or accuracy decreases when you drop a variable. So the larger the decrease, the more significant the variable is. Here the mean decrease is significant parameter for selection, and the Gini index can describe the overall explanatory power of the variable. Now the question comes, what is the difference between the random forest and the decision tree? Random forest is a set of the multiple decision trees, but the decision tree is just a decision tree. And the deep decision trees may suffer from overfitting, but the random forest prevents the overfitting by creating trees on a random subset. So the moreover, if you read the original papers of a random forest, you will find that their random forest never overfit. So there is no question of the overfitting in case of the random forest. Decision tree are computationally faster, but the random forest is not a faster, because random forest itself work with so many it creates so many decision trees. So technically random forest will be slower than the decision tree. Random forest is difficult to interpret, while a decision tree is easy interpretable and can be converted to the rule like if-else rules. And decision tree mimics kind of a human decision making the techniques. Okay, right, so this is all about the theory. Now let's go ahead and first start working with the random forest as a regression. So first of all, we need to import important packages into Jupyter Notebook. So let's go ahead, first import pandas as pd, and then import numpy as np, and then import seaborn as sns, and then import matplotlib .pyplot as plt. And since we are working with the Jupyter Notebook, you need to also give here matplotlib inline command there. And now we are going to import dataset metrics, train test splits, and the random forest regressor from sklearn. So let's go ahead and import from sklearn datasets and metrics, and then from sklearn dot model selection import train test split, and then from sklearn dot ensemble import random forest regressor. Okay, perfect. So the first of all, we are going to take a very famous dataset, diabetes dataset. Okay, diabetes is equal to datasets dot load diabetes. Now we will get our diabetes dataset. Let's go ahead and see what are the keys in the diabetes dataset. The key of the diabetes dataset is the data, target, description, feature name, etc. Now let's go ahead and see the description of diabetes dataset. Okay, so the description is here. The baseline variable is age, sex, body mass index, body blood pressure, and 6 blood serum measurements were obtained for each of 442 subjects which were suffering from the diabetes. And in the response, which is the target, and target is the quantitative measure of a disease progression after 1 year of a baseline. So there are total 442 instances of the data, and then it has 10 features, or you can say the 10 columns, and then it has of course a target there, and this is the feature name, age, sex, body mass index, average blood pressure, S1 to S6. Okay, and here is the source URL presents there. You can also read more about this dataset. Perfect. Now let's go ahead and get these data into X and Y vector. So in X vector we can get here y diabetes dot data, and in the Y vector we can get this data by diabetes dot target. Okay, now let's go ahead and see the shape of X and Y there, and then we have here X train, and then we have X test, and then we have here Y train, then we have Y test is equal to train test split XY, and then test size. Okay, and then it has random state is equal to the 42. Okay, so here we have a train test split, XY test size is 0.3, random state is 42. Now let's go ahead and see here regressor is equal to random forest regressor, n underscore estimator is 100, and then the random state I'm gonna set here 42 so that we can get a same result. Okay, and then here we are going to put here the regressor dot fit X train and then Y train, and then we are going to predict Y pred is equal to regressor dot predict. Okay, and there we are going to get here X underscore test. So here we have got our Y using a random forest. So let's go ahead and plot Y predicted and the true value, and we can do that by using matplotlib there. So the plt dot figure is fig size is equal to 16 by 4, and then plt dot plot, and there we are going to plot here Y pred, and then plt dot plot here then Y test. Okay, so here you see here we have our the predicted and the test value. So the blue one is our predicted value and orange one is our original or true value. Okay, now let's go ahead and get the mean absolute error and mean square error and root mean square error. Okay, for a root mean square error, what we need to give for root mean square error, we need to get here the np dot sqrt. Okay, and then matrix dot mean square error. Okay, so there we need to pass here the true value of y and then predicted value of y, and there you will see here it's 53.5, right? So this is the root mean square error if we use random forest classifier. In a previous tutorial, if you go ahead and see in a decision tree there, what was the error? Root mean square error. So let's go ahead and see the error. The error was 70.61, okay, in a decision tree. But if we use a random forest, in a random forest, it is a 53.50. Now you can see here, it has reduced drastically. Overall percentage, if you see here, there are 72.78, okay, 72.78 minus 53.50 divided by 72.78. So the error around the 27% or 26% error has been decreased. Okay, so the moreover, okay, otherwise you can just otherwise the error was more in a decision tree, in case of the decision tree. Now let's go ahead and see the standard deviation. In a standard deviation ytest.std, standard deviation is 73.47. So the moreover, now the error is less than standard deviation of actual y. So the moreover, now we can say that this is a pretty good model. Okay, so this is how you can use random forest regression while working with the regression task. Now let's go ahead and see random forest as a classifier. Now let's go ahead and start with the random forest as a classifier with the iris dataset. So we need to first download our iris dataset from sklearn the dataset, and we need to also import the random forest classifier from sklearn. So let's go ahead, create a sklearn ensemble, import random forest classifier, and then here we are going to get here the iris dataset is equal to the datasets dot load iris dataset, right? Perfect. Now let's go ahead and see the iris dataset, the target names. So these are the target names, and I'm also going to get the description of iris dataset, which we can get from DSCR. So the iris is iris plants. It has a total 150 instances, and there are 4 numeric attributes, which you can say the 4 feature. And the feature is sepal length, sepal width, and petal length and width. And it has 3 target classes: iris, iris flower setosa, versicolor, and virginica. Right? So it's a very famous iris database, first used by Sir R.E. Fisher. The dataset is taken from Fisher's paper. Note that it's the same as in R, but not as in the UCI machine learning repository, which has 2 wrong data points. So this is kind of the corrected data set. Okay. Now let's go ahead and read this data set into X and Y vector. Iris.data, and then Y is equal to iris.target. Right? Perfect. Now here, let's go ahead and split this with X-train and the X-test, Y-train and the Y-test is equal to the train test split X, Y, random state is equal to 1. And then here we have test size is equal to 0.3, and then here we have a stratify is equal to y. Okay, then here we have a CLF is equal to random forest classifier n underscore estimator is equal to 100, and random state is equal to, random state is equal to the 42, so that you can also get the same result which I'll get. And then clf.fit, classifier.fit, there we have x train and then y train. Now let's go ahead and get y prediction there. Y pred is equal to clf.predict. There I need to pass here x underscore test. Okay, perfect. So let's go ahead and get the accuracy here. So what is the accuracy? Accuracy is the matrix dot accuracy score. There I need to pass here y test and y pred. So it says that the accuracy is 97.7%. If you remember, in our decision tree we had got accuracy of 96.67%, right? You see here accuracy is 96.67%, but here the accuracy is 97.77%. So it is a kind of an increase of 1% accuracy if we use a random forest classifier for an iris dataset. Perfect. Now let's go ahead and plot a confusion matrix for it. For a confusion matrix, we need to first get a confusion matrix, which we can get from matrix.confusion matrix. And there we need to pass here y test and then y pred. Now we have got here a matrix, confusion matrix. Now let's go ahead and draw this confusion matrix in a beautiful the image using a Seaborn heat map library. So here we have SNS heat map and then mat, and apart from that I'm gonna pass here a note is equal to the true, and then the format FMT is decimal. That means the number will be represented into the decimal format, and the C bar is equal to the false, and there I'm gonna put here X label is equal to the iris dataset dot target name, and the Y tick label is equal to also iris dataset dot target names. Okay, apart from that I'm gonna also put here X label. So here X label is our predicted value, and then PLT dot Y label, which is our true value. Okay, so let's go ahead and see this. So here you see we have got Satosa, versicolor and Virginica. This is the predicted one and this is the true. So here you see for Satosa 15 out of 15 is the correct, and for versicolor there is a 15 true and 15 is correct. But for Virginica, if you see here, the true is 15, but it has predicted one Virginica into versicolor. Okay, so that's why here we have got a 97.77% of the accuracy. So now let's go ahead and see what is the advantage and the disadvantage of the random forest classifier and the regressor. Random forest is considered as a highly accurate and robust method because of the number of decision trees participating in the process. It does not suffer from overfitting problem. The main reason is that it takes the average of all the predictions, which cancels out the bias. The algorithm can be used in the both classification and the regression problem. Random forest can also handle missing values. There are two ways to handle these: using median values to replace the continuous variables, and computing the proximity weighted average for a missing values. You can also get the relative feature importance, which helps in selecting the most contributing features for the classifier. So let's go ahead and see with the CLF. Then if you type here the help CLF, you see here. So this is how the random forest classifier work there. Okay, so you get all those things. Let me get you the importance. Okay, so these are the attributes there. Okay, perfect. So it returns by predicting XY. Let me see what is the return. Yeah, here it has a feature importance. So if you type here CLF dot feature importance, then you will see here The most important features are these last two. Okay, so iris dot feature names. So the petal length and the petal width are most important features, and the least important feature is a sepal width. Okay, perfect. So this is how we can get a feature importance from a random forest. And apart from that, there are few disadvantages of the random forest as well. Like a random forest is slow in generating predictions because it has a multiple decision trees. Whenever it makes a prediction, all the trees in the forest have to make a prediction for the same given input and then perform voting on it. And the whole process is time consuming. And the model is difficult to interpret compared to a decision tree where you can easily make a decision by following a path in the tree. So this is all about a random forest classifier and the regressor in a machine learning. And thank you so much for watching this video. Please do not forget to subscribe this channel so that you can get updates directly into your inbox. Bye bye. Have a nice day.